Hello everybody, today I will show you how we can visualize a problem here, an optimization problem in a two-dimensional graph. We have two variables, x1, x2. We have an objective function that we're trying to maximize subject to a total of 6 different constraints. So the first thing I would like to do is visualize the constraint that I would call easy to put in 2 dimensions. Alright, so let's look at the first one, x1 less than 6. x2 less or equal than 4. So x1 here is the x-axis, x2 is the y-axis, x1 less or equal than 6, right? So I would put my position here with 6, okay, right here, and anything in that area would be called feasible. Now, we also have x1 greater or equal to 0, which would be over here. I mean, I can quickly draw this constraint right here. And anything in that direction would be fine. We have x2 greater or equal to 0, right? So that would be anything here that is positive, okay? And then we have anything x2 less or equal than 4, so that would come here, up, and this one x2 less or equal than 4. So now we already have an idea of what our feasible region is made out of using those 4 different variables. Alright, after mapping those 4 last constraints, I'm going to map those 2 here. That one, x1 plus 3x2 greater or equal than 6 here. That's pretty straightforward. So what do I need to do here? If x1 is equal to 0, how much should x2 be equal to in order to be equal to 6? So if x1 is 0, then x2 should be equal to 2. Okay? So 0 and 2 here. Okay, perfect. And then if x2 was equal to 0, x1 would have to be equal to 6. So that would be 6 and 0. Right here and right here. And I'm going to draw this line. Now, I'm not going to draw the line beyond the axis because we know that it should be within those axes. Okay. And what I'm saying is that it should be greater or equal than 6, so it's going into that direction. You can do a test if you're not sure the direction. Let's take, for instance, 0, 3. I plug that in. 0 plus 3 times 3, 9 is greater than 6. Okay, that's good. Alright? And then we're going to do this very last one here. 5x1 plus 2x2 greater or equal than 10. If x1 is equal to 0, then x2 must be equal to 5 here. And if x2 is 0, then x1 should be equal to 2. So, in this case, that would be this one. Alright? Here we go. And that should be greater than 10, so it's also in this direction. So now what we see is that we have the feasible region, which is essentially right here. And our last part will be to map the objective function value. Alright, I have zoomed in a little bit so you can better see. The objective function here, x1 plus x2. So essentially, what we know is that, let's suppose, we're going to take some example, right? Let's suppose that I want to have an objective function is equal to 5. So in order to get 5, right, I could say 0 and 5 is good, or 5 and 0 is good, okay? So let's map this, 5, 0, and the other one at 5 here. So that would be one objective function, okay? Let's right here, okay? If I was to do 6 and 6, for instance, that would be an objective function of 6, right, and so on, and so on and so forth. And so what we see is that the objective function is going to increase because we're maximizing this way. And if I keep going here, I would find that my optimal will be somewhere here, and I anticipate that would be 6, 4. Okay, 6 and 4, that would be objective function value of 10. Okay. That would be my optimal. I am going to show this now in CPLEX. And alright, as promised, I will show you here in CPLEX a little bit more about how the problem can be solved. I have written our problem here in a notepad document, maximize x1 plus x2 subject to the 6 constraints, and then I end it with the term end. Okay, unlike the knapsack, those are not binary variable. And then I've opened CPLEX, pretty straightforward. And then I'm gonna type read here, drag this here, and then put LP afterwards. Okay, then I would put OPT for optimize, and then it would tell me essentially that I have a solution here that is equal to 10. Okay, and if I want to see the solution, let's say display solution variables with a S, then I can see all of them, and star, and then it would tell me that x1 is equal to 6 and x2 is equal to 4. So this is the same that we saw earlier when we tried to visualize it in 2 dimensions.